Jai Hind everyone. Today we are going to start our second unit with the topic that is supervised learning and unsupervised learning. So this is a diagrammatic representation of understanding what a supervised learning and unsupervised learning is, right? So in the case of supervised learning, we can see there is a teacher, or you can say there is an instructor who is instructing a particular student, right? Okay. In the unsupervised learning, here we see the student is writing something or it is trying to learn something by its own. It's no any other instructor is there. No one is instructing that student, right? And here we are having a reinforcement learning, right? Another type of machine learning, that is we have reinforcement machine learning. Fine. So for one by one, we will be discussing each one of them. First, the supervised learning algorithm. What is the supervised learning? Likewise, we have seen in the previous slide that there must be some instructor. There must be some trainer or a teacher is available who is instructing, right? Then the student is able to understand, and then it is trying to behave like that, in that manner, in whichsoever manner that student has been trained. Fine. Similarly, we can see with the help of this example that we are providing input raw data. Fine. What is the input raw data? It is pineapple, right? We are giving input, that is a pineapple, and here we are having a supervised machine learning model. Fine. So what it needs to do, it will be checking out what the input it is getting. If instead of this shape, this angle of the particular object, if it is having some different angle, if it is a new input for that, it has to identify, and then the new response it will generate, okay, this is a pineapple. That's how this model will be working, right? So in the supervised learning, we have the predictor variables and target variables. Also, we say the response variables, right? And for each predictor variable input, we get the target variable output. Fine. The true output value of the target variable for the given input is already known, right? Some teacher is there, some instructor is there who is teaching this model, who is telling this model what this is, right? So in the supervised learning, you train the machine using the data which is well labeled, right? Which is well labeled, which is known, right? It means some of the data is already tagged with the correct answer. Okay, these are the correct answer, these are the things, and these are the input, or like we have seen the image was labeled that it is a image of a pineapple, right? It can be compared to learning which takes place in the presence of a supervisor or a teacher, as we have seen, right? A supervised learning algorithms learn from labeled training data, right? It helps you to predict outcomes for unforeseen data. Successfully building, scaling, deploying accurate supervised learning machine algorithms, the data science model takes time and technical expertise from a team of highly skilled data scientists, right? Moreover, data scientists must rebuild models to make sure the insights given remains true until its data changes, right? So that is how it is working. Now the question arises, why we are using supervised learning? Supervised learning allows us to collect data or produce a data output from previous experiences. Fine. It helps you to optimize the performance criteria using its experiences. Fine. What does it mean by the experiences? It is collecting the data from the data it is already having, the events which has been passed in the which has been occurred in the past. Supervised machine learning helps you to solve various type of real world computational problems as well. Fine. Now we see what are the unsupervised learning. What does it mean by unsupervised learning? As we have seen in the case of supervised learning, that there must be some teacher, some trainer, some instructor to train the students. Then these models are working on the basis of the labeled data, right? Like we have seen, okay, the image is there and it is being labeled that it is a pineapple, right? Here we can see we have not labeled the images. This is a raw data. Fine. Some of the algorithms are working over there and then they will be segregating. Okay, these are the some triangles, this is another shape, this is another circles and so on, right? So in unsupervised learning, the machine is trained with unlabeled data and finds the patterns between the data based on the different properties of the data. Like this one, suppose what it will do, it will try to find out the pattern. What is the pattern that is being followed in the neighbors, right? Then it will grow. Okay, there is no output label in the data so that machine can identify the relationship. Fine. So what it has done, it has created some of the clusters of the similar type of objects, right? Clusters of triangles and then this and then this one, hexagonal, octagonal, circular shape, triangular shape, rectangle, square. Suppose there is a mixing of objects, right? So the unsupervised learning algorithms will work on that, will check out this similar kind of pattern and then they will create the clusters and they will identify. So now the question arises, what is unsupervised learning? Unsupervised learning is also a machine learning technique where you do not need to supervise the model, right? Likewise, we have seen in the case of unsupervised, in the case of supervised model, there was a trainer, there was a teacher, right, who was instructing the students. But in the case of unsupervised learning, here we do not supervise the model. Instead, we need to allow the model to work on its own to discover the information, right? It mainly deals with the unlabeled data, right? So why unsupervised learning? Here we are having some of the prime reasons for using unsupervised learning, like unsupervised machine learning finds all kinds of unknown patterns in the data. Like we have seen in the previous slide, there was a group of objects in which we were having some of the objects of a particular shape, some of another shape and so on, right? Unsupervised machine learning find all kinds of unknown patterns in the group of data, right? It also helps us to find out the features which can be useful for categorization, right? Like we have seen, how many categories of shapes are there? 3 categories of shapes are there, right? So it is used to categorize the patterns as well, right? It has taken place in the real time. So all the input data to be analyzed and labeled in the presence of learners, not the instructor, in the presence of learners itself. It is easier to get unlabeled data from a computer than labeled data, which needs manual intervention, right? So now we will be discussing some of the important differences in between supervised learning and unsupervised learning. Here we are having few of the parameters, right, on the basis of which we will be differentiating supervised learning and unsupervised learning. Fine. So, first parameter I am going to discuss, that is process. In a supervised learning model, input and output variables will be given, right? In unsupervised model, only input data will be given. Fine. Okay. What is the input data? Algorithms are trained using labeled data. Here, algorithms are used against data which is not labeled. Fine. What are the algorithms used in the case of supervised learning and unsupervised learning? In case of supervised learning, we have SVM, that is support vector machine. We have neural network. We have linear and logistic regression, random forest, and classification trees. While in unsupervised algorithms, it can be divided into different categories like cluster algorithms, k-means, hierarchical clustering, and many more. What about the computational complexity? Supervised learning, as we are using the labeled data, right? So, it is a simpler method. Unsupervised learning is computationally complex because it is learning from the environment and then it is working, right? So, use of data, supervised learning model uses training data to learn a link between the input and the outputs, right? Unsupervised learning does not use output data. Then what is the accuracy of results? Because it is working on the label data and input is known to this highly accurate and trustworthy model, it is less accurate as compared to supervised learning model but trustworthy method, right? Real-time learning method in supervised learning model take place offline, while learning method takes place in real time in unsupervised learning model, right? Number of classes, in the case of supervised learning, the number of classes is already known in the case of supervised learning, while the number of classes is not known in unsupervised learning, right? So, what is the main drawback of using supervised and unsupervised learning? While I talk about supervised learning, the classification of big data, when we have a huge amount of data, a large amount of data we are having, it can be a real challenge in supervised learning. Here, you cannot get precise information regarding data sorting and the output as data used in unsupervised learning is unlabeled and not known, right? So, that was about supervised learning and unsupervised learning, and in the very first beginning of the introduction, we have seen that third type of learning algorithm we also have, that is a reinforcement learning, right? So, we have seen what the supervised learning method is, right? Now, we will see what is a reinforcement learning and how it is different from supervised learning, right? When we talk about reinforcement learning, it typically works on the basis of getting an award or punishment, right? Accordingly, it behaves, right? Reinforcement learning is all about making decisions sequentially. In simpler words, we can say that the output depends on the state of the current input and the next input depends on the output of the previous input, right? Okay, maybe it is quite confusing in a beginning, but we take the example of games. The output of the next pass will depend on the input of the previous one. What action has taken by the player, accordingly second step will be taken, right? In the case of supervised learning, we have seen the decision is made on the initial input or the input given at the start, right? In reinforcement learning, decision is dependent. Dependent on what? Dependent on the input, right? Accordingly, it will behave. Okay, so we give labels to sequences of dependent decisions. For example, chess game, right? Decision is dependent. On which it depends? It depends on the like what action the player 1 has taken. Accordingly, player 2 has to take the action, right? Here we have some of the important points in the reinforcement learning. It would be much clearer now. The input should be an initial state from which the model will start. What will be the output in that case? There are many possible outputs as there are variety of solutions to a particular problem, right? The training is based upon the input, what the input it is getting. Then the model will return a state and the user will decide to reward or punish the model based on its output. When we are playing a game, whether the move of the player 1 was correct or incorrect, right? Accordingly, another player will take a move and so on, and we'll see what the output is. Fine. So there will be the punishment if it is working, if it is not working well, and a reward if it is perfectly working. The model continues to learn, right? The best solution is decided based on the maximum reward. If maximum number of times it is getting an award or a reward, then we say, yes, this model is perfectly working, or this is good, or this is not good. So, in the case of machine learning, as we have started with machine learning, we have seen that supervised learning, unsupervised learning, and reinforcement learning, 3 algorithms are there, right? Now we focus on supervised learning. We see we have classification and regression in the case of supervised learning. So what are the classification and regression? Classification, as the name is indicating by itself, this is a task of predicting a discrete class label. In simple words, whether it belongs to class A or class B, right? We are categorizing the things. We are creating the classes, like whether a mail is a spam or non-spam. It cannot be both. A mail cannot be both, okay, this is a spam as well as this is important or this is authenticated, right? It cannot be both. Fine. Either mail belongs to a spam or non-spam, in simple words, right? In a classification problem, data is classified into one of 2 or more classes. Like we have seen the example, mail either belongs to spam class or non-spam class, right? A classification problem with 2 classes is called binary. More than 2 classes is called multi-class classification. While if we talk about regression, this is the task of predicting a continuous quantity. Regression is the task of predicting a continuous quantity. Fine. Regression problem requires the prediction of a quantity. The regression problem with multiple input variables is also is called a multivariate regression problem. Fine. That means we will be having some of the dependent variables, some of the independent variables, right? Then what is the correlation in between both of them? That's what we will be identifying, right? For example, with the time, what is the impact on the prices? Okay, this is what predicted price. That yellow dots, it shows the actual price. Fine. As soon as the time passes, then we can see how the predicted price are getting increased. Fine. That means how these are dependent. What are the dependent variables? What are the independent variables? We will be discussing. So now the question arises, what exactly the regression analysis is? Regression analysis is a form of predictive modeling technique so that we can predict, which investigates the relationship between a dependent variable and independent variable. What is a dependent variable? Dependent variable is a target variable. What is the independent variable? Independent variables are the predictors. That means if I increase, for example, if I increase my advertisement, say by 10%, what is the impact on the sales? Right? If student increases his or her study hours in the examination time, what is the impact on the grades? Right? So, dependent variables are the target variables and independent variable are the predictors. Generally, the dependent variable is one where independent variables could be multiple, right? This technique is used for forecasting, time series modeling and finding the causal effect relationship, right? Okay, if this happen, what will be the impact or what will be done between the variables? For example, relationship between rash driving and the number of road accidents by a driver is best studied through regression analysis. How it is so? We can easily see. Suppose n number of data we are having where the driver was doing a rash driving. Then we can see, we can analyze what is the number of road accidents in that case. So, we can easily see with the help of regression analysis. So, regression analysis is an important tool for modeling and analyzing the data, as we have seen, right? Here, we fit a curve or a line to the data points in such a manner that the differences between the distances of the data point from the curve or the line is minimized. What is the requirement of regression analysis? Why do we use regression analysis? Regression analysis estimates the relationship between two or more variables, right? Let's understand with the simplest example. Let's say you want to estimate growth in the sales of a company based on the current economic conditions. You have the recent company data which indicates that the growth in the sales is around 2.5 times the growth in the economy, right? Using this insight, we can predict future sales of the company based on current and the past information. There are multiple benefits of using regression analysis. They are like, it indicates a significant relationship between the dependent variables and the independent variables, as we have seen in the previous slides. It indicates the strength of impact of multiple independent variables on a dependent variable. Regression analysis also allows us to compare the effects of variables measured on different scales, such as the effect of price, changes and the number of promotional activities. The benefits help market researcher, the data analyst, the data scientist to eliminate and evaluate the best set of variables to be used for building the predictive models. So that's how we can see how regression analysis is important. Now, we are having different type of regression techniques, like it could be the number of independent variables, shape of the regression line, type of the dependent variable. So here we can see the examples of the regression. We can have linear regression, we can have logistic regression, we can have multiple regression, ridge regression, lasso regression, and many like so on. Fine. So we'll take few of the examples like linear regression and logistic regression in the current lecture. Rest we will be discussing in the next working lecture. So linear regression, when we talk about, when there is a linear relationship between the dependent and the independent variable, as the name is indicating by itself. Linear regression simply says how linear relationship, how there is a relationship in between independent and the dependent variables, right? What is a linear relationship in between them, right? Logistic regression says when the dependent variable is categorical, say either yes or no, either true or false, in simple words. Fine. Either like male belongs to spam or not spam, it cannot be both. Either the gender of a person is male or a female, class A, class B, and so on, right? When the dependent variable is categorical in nature, we do logistic regression. The third one, we have polynomial regression, when the power of independent variable is more than one, right? Then we use polynomial regression. So now we'll see the linear regression. As the name is indicating, in this technique, the dependent variable is continuous. Independent variable or variables can be continuous or discrete. There could be n number of independent variables, right? So it can be continuous or it could be discrete as well. And the nature of regression line will be linear, right? So linear regression establishes a relationship between the dependent variable and one or more independent variables using best fit straight line. This best fit straight line is also known as regression line, right? It is represented by an equation that is y equals to a plus b into x. The equation of line from our very early childhood we are studying, y equals to mx plus c, right? A plus bx plus e. What is this e over here? E is the error term. A is the intercept, b is the slope of the line, and e is the error term, right? This equation can be used to predict the value of target variable based on the given predictor variables, right? Here in this example, we have tried to identify the relationship between the weight and height, right? If height is 120, then weight in kilogram, then height in centimeters we have measured over here. If the height is 100, if the height is 120 centimeters, if the height is 140 centimeters, and so on. Accordingly, we have identified, okay, what is the height, right? Multiple number of times in the regression analysis, we have used dependent variable, independent variable, and we have seen what the dependent and independent variable is. The response variable whose value needs to be predicted, that means impact on sales. If I increase, say, the advertisement by marketing, right? Independent variables, the predictor variables used to predict the response variables. right? So in this, when we use equation, we have seen what is A, what is B, and so on, what these variables are meant by. So this indicates the intercept, this variable indicates the slope, then X is what? Independent variables, and E is a error term. Fine. This is just the diagrammatic representation of the equation. Fine. Second regression, that is a logistic regression. Logistic regression, what it says? Logistic regression is a method used to predict a dependent variable given a set of independent variables such that the dependent variable is categorical, right? Dependent variable and independent variable. Fine. The response, binary variable holding values like 0 or 1, yes or no, A, B, C, and so on. That is Boolean, right? We have to take. Independent variables, the predictive variables used to predict the response variables, right? This is a linear regression use case to forecast monthly sales by studying the relationship between the monthly e-commerce sales and the online advertisement cost, right? Here we can see these are the monthly sales, 200, 400, 600, 800, and so on. Here advertising cost, say at 1, 2, 3, 4, and so on the scale of this, right? So that is how we can identify the relationship in between monthly sales and the advertising cost using linear regression. And this is a use case for logistic regression to a school or not admitted based on CGPA, right? If CGPA is, say, greater than 5 or greater than 6, then student is likely to get the admission, right? Say admission 0. Why? Because CGPA is 4.2. CGPA is 5.1, 5.5. It is what? 0. If it is greater than 6, for example, then students are likely to take the admissions, right? So that is how we can identify the relationship between the dependent and independent variables, right? This is just a graphical representation of how the output will be looking like in both of the cases, like linear and regression model. And here these are the references from where I have covered the contents in my slides.